We will be talking about the admittance parameters in this slide, the few slides, about 13 slides. Now, admittance parameters is one of the 6 parameters of two-port network. Admittance parameter is also called Y parameter, and it has Siemens as its unit. It is also used in synthesis of filters, is used in impedance matching of network systems, and also it is in power distribution network. Also, just like in two-port network can be voltage driven or current driven. In impedance parameter is majorly voltage driven, and the admittance parameter is current driven. That does not mean you cannot transform the source from voltage to current or current to voltage, please. And that is why impedance and admittance are very related, because they can be transformed. They can be transformed to each other, as we will see later on in the course. Now, this is a two-port network for calculating admittance parameter. Now, in this network, you see your current source, high 1, supplying current high 1 and having a voltage drop V1, and your V2 equals to 0, that is to be short-circuited, and your high 2 will be flowing. That your I2 is due to the current source, high 1. Later, we will get to that later. Now, the general formula for your admittance parameter is high 1 equals to Y11 V1 plus Y12 V2, and high 2 equals to Y21 V1 plus Y22 V2. Now, to calculate for your Y11 and your Y21 in these two general formula, your V2 must be equals to 0. That is, your output voltage must be short-circuited, must be equated to 0 to get your Y11 and your Y21. Later, we'll talk more on that. Similarly, to calculate for your Y12 and Y22, your input voltage, that is V1, must be short-circuited. Your V1 must be equals to 0. And your Y12 and Y22 can then be calculated when you equate your V1 to be equals to 0. Then you should also note that your I2 is the current producing your high 1. This, you have better understanding of this when we get to the example, but take note of that your high 2 is the one producing the high 1, and your V1 will be equals to 0 when you are calculating your Y12 and your Y22, and your V2 will be equals to 0 when you are calculating for Y11 and your Y21. These are the general formula for calculating admittance parameters, which was stated earlier on, and this formula can be put in a matrix form, 2x1 matrix form. I1 and I2 equals to 2x2 matrix, Y11, Y12, Y21, and Y22 multiplied by another 2x1 matrix, V1 and V2, and that will lead to a 2x2 matrix. Admittance parameter is also Y parameter, and the unit is Siemens. We already said that. And your V1 must be equals to 0 for you to calculate your Y12 and your Y22. And to calculate for your Y11 and your Y21, your V2 must be short-circuited, or V2 must be equals to 0. Please take note. Mathematically, your Y11, also called short-circuit input admittance, is equals to your input current over input voltage when your output voltage is equals to 0. this I1 over V1, provided that V2 equals to 0. Also, short circuit transfer admittance from port 1 to 2, that is Y12, will be equals to the input current over output voltage I1 over V2, provided that your V1, that is the input voltage, is equals to 0. And your Y21 short circuit transfer admittance from port 2 to 1 will be equals to output current over input voltage, provided that your output voltage equals to 0. And your short circuit output admittance Y22 will be output current divided by output voltage, provided that your input voltage is equals to 0. Note that we have certain condition also when Y11 is equals to your Y22, that will be a symmetrical situation. It will be a symmetrical admittance circuit. Then when your Y12 also is equals to your Y21, it will be a reciprocal admittance circuit. The impedance and admittance parameter are collectively referred to as admittance parameter. And when the two-port network is linear and has no dependent source, the transfer admittance, that is your Y12 and Y21, are equal, and the two-port network is said to be reciprocal. We have the reciprocal if the point of excitation and response are interchanged. You can interchange the response and the excitation. Then we'll say that the admittance parameter in such case is reciprocal. And for a reciprocal network, it can be modeled following the pi network shown in this slide. If the admittance parameter of the two-port network is not reciprocal, that is, if your Y12 is not equals to Y21, then you can represent the network following the pattern shown in this slide. That is, you can connect the elements in this slide when your admittance parameter is not reciprocal. Is a question. The question is a question. The question states that we should obtain the Y parameters, that is Y11, Y12, Y21, Y22, for this pi network. Pi network is simply telling you how the elements are arranged in form of a pi. Question. Remember in slide 2, we said for you to calculate your Y11 and your Y21, you must place a short circuit at the output voltage, that is your V2 must be equals to 0 for you to calculate your Y11 and your Y21. And that is what we just did in this diagram. We place our short circuit across the 8 ohm resistor. Please don't mind the drawing. It's supposed to be a resistor, because what we are having there is just like an inductor, but it's a resistor. So when the short circuit is placed across the 8 ohm resistor, we will have the 2 and 4 ohm resistors to be in parallel. The 8 ohm resistors will be neglected, then the 2 and 4 ohm resistors, they will be in parallel to each other. Now, using the Ohm's law, V equals to IR. Remember, your 4 and 2 ohm resistor are in parallel. 8 ohm resistor is no longer there because it's been short circuited. So your V1 will be equals to your I1, which is not known yet, multiplied by your equivalent resistor, that is 4 and 2 in parallel, which is 4 over 3. And that will give you V1 equals to 4 over 3 I1. Placing that into the formula for your Y11. Your Y11, remember the formula is I1 input current over input voltage when your output voltage is equals to 0, that is I1 over V1, and that will simply give you 0.75 Siemens. Now your Y21 from the formula will be equals to your output current over input voltage, that is I2 over V1. I2 is an extension of your I1, that is your I2 is the current flowing in the is a part of I1 flowing in the 2 ohm resistor. I2 is a part of I1, that is current 1 input current flowing in the 2 ohm resistor, but in a negative direction because it is flowing in opposition to the input current, and that's why we have our I minus I2 will be equals to, using current divider principle, 4 over 4 plus 2 multiplied by your I1, and that will give you 2 over 3 I1. Put that or substitute that back into your formula. Your Y21 will be equals to I2 over V1, and you will get minus 0.5 Siemens. Principle and calculating for your Y12, that is calculating for your short circuit transfer admittance from port 1 to 2, and calculating for your short circuit output admittance, that is your Y22, you will have to place a short circuit at the input voltage, that is your V1 will be equals to 0. Place a short circuit. When you place a short circuit there, your 4 ohm resistor will be equals to 0, will be short circuited, making the 2 ohm resistor and the 8 ohm resistor to be in parallel. Now, by your formula, your Y12 is input current over output voltage, and your Y22 is output current over output voltage, I2 over V2. Now, we need to know our I2 and our V2. Our V2 from the Ohm's law is I over R. That is I2, the current I2 multiplied by the equivalent resistor. Equivalent resistor is 8 ohm and 2 ohm in parallel, and that will give you 8 over 5 multiplied by your I2, which is not known yet, 8 over 5 I2. Substitute that into the formula for your Y22. That will be I2 over V2, and you will get 5 over 8 Siemens, or 0.625 Siemens. Now, to calculate for our Y12, which is I1 over V2. Now, we'll do that in the next slide, but you must take note that your I1 in this case, when your V1 has been short-circuited, your I1 is produced by I2. It is a part of I2 that is flowing through 2 ohm resistor. Your I1 is a part of I2 that is flowing in 2 ohm resistor, but in opposite direction. So your I1 will be minus 8 over 8 plus 2 multiplied by the total current flowing in the circuit, which is I2, using current divider principle. You will see that in the next slide. Said earlier on, using current divider principle, your minus I1 is minus because it is flowing in opposite direction to the current source that produces it. It's flowing in opposite direction to I2 that produces it. Remember, it's a part of I2 flowing in the 2 ohm resistor. So using current divider principle, your minus I1 will be equals to 8 over 8 plus 2 multiplied by your I2, and that will give you 4 over 5 I2. And your Y12, substituting your I1 into the formula for your Y12, you will have Y12 equals to I1 over V2, and that will give you minus 0.5 Siemens if you substitute your I1 and V2 into the formula. Now, also note that if you go to slide 10, you will discover that your Y21 and your Y12 in slide 12 are the same. That is, your Y12 and Y21, they are the same, meaning it is a reciprocal network of admittance parameter. The admittance parameter is reciprocal. Admittance parameter is reciprocal. So please take note. An exercise for you to do questions say that you should obtain y11, y12, y21, and y22 for this T network. Please try it on your own, do it, and then I believe that you should be able to get the answer. Thank you.